Some series to integral calculus. Some series to integral calculus. This is the discussion that we are proceeding upon. Some series to integral calculus, and mind-blowing discussion that we have started, that is 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8 plus 9. Okay, there is one examination, and in examination it is written as 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 5 minus 6 plus 7 minus 8 up to 33. Can you write what it is? Simple, right? 1 minus 2 plus 3 minus 4 plus 5 minus 5 plus 6 and so 33. What is the result? Can you write? Okay, two methodology we have already seen in the past two videos. Two methodology we have already seen. And what are these two methodologies? Two methodology is first compute the odd number, then compute the even number separately. Compute the odd number, compute the even number separately, and subtract it because all even number are in negative. Minus 2, minus 4, minus 6, minus 8, and all the odd numbers are positive 1, 3, 5, 7, 9, and so on. Second thing we did is we brought up into a scale of where sampling has been done in zero point 0.5, zero point 0.5, zero point 0.5. What is sampling, what is 0.5, 0.5, that we will see. Consider there is a function. If I say I have 1, consider there is nothing called negative here. All are positive. Consider in that fashion. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If that is the case, then consider, okay, consider this is x-axis, this is x-axis, this is y-axis, x-axis, y-axis. Now it is x equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Consider in this manner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When x equal to 1, then I have y as 1. When x equal to 2, I have y as 2. When x equal to 3, I have a y as 3. This is what anyone would understand. What we did in the past video, consider when x equal to 1, then height is 1. When x equal to 2, then height is 3. When x equal to 3, then height is 5. When x equal to 4, height is 7. When x equal to 1 and a half, then height is 2. When x equal to 2 and a half, then height is 4. When x equal to 3 and a half, then height is 6. Makes sense? Means x-axis we have done. What do you mean? I am saying that can we consider, if I am taking in this manner, can we consider all height as a 2x minus 1? Okay, I'm writing 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 up to 33. Consider in this manner. Then can I rewrite as 2x minus 1, 2x minus 1, 2x minus 1, 2x minus 1 33 times? What do you mean? Where x starts at 8, x starts at 1, 33 times, not up to 33. Where x is 1, 1 and a half, 2, 2 and a half, 3, 3 and a half, 4, like so. In 33, count. When 2x minus 1, x is 1, then it is 1. When x is 2, then it is, I'm sorry, when x is 1 and a half, then it is 2. When x is 2, then it is 3. When x is 2 and a half, then it is 4, like so. So can I rewrite this problem as summation x equal to 1 to n, where x is growing half, 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 fx. Mean fx, fx, fx plus fx plus fx plus fx plus fx n times, where first fx is x, first fx is x, at x equal to 1. Second fx is x equal to 1 and a half, 3 by 2. Third is fx equal to 2. Fourth is fx equal to 5 by 2. Fifth is fx equal to 3. Sixth, and so and so. Okay. Now, wherever I have x equal to 1, 2, 3, 4, 5, 6, fx will be 1, 3, 5, 7, 9, all odd number. Wherever x is in fraction, 1.5, 2.5, 3.5, 4.5, 5.5, and so on, then fx will be 2, 4, 6, 8, something like that. Okay, this is what we did in last video. Very precious video, very precious explanation how we can achieve this through successive approximation. Successive approximation means if I have a x-axis and consider I am attaching all the odd number. What do you mean? X equal to 1, height is 1. X equal to 2, height is 3. X equal to 3, height is 5. X equal to 4, height is 7. If I connect all the top points like this, 1, 3, 5, 7, then this falls in function called 2x. I'm sorry, this falls in a function called 2x minus 1. Derivative will be 2, means it will be connected by a straight line. Consider this is a straight line. Consider this is a straight line. Okay, means this is function over x, and function over x is sampled at x equal to 1, 2, 3, 4, 5, 6. At 6, the height is 9, I think so, above 6 into 2, that is 12. 6 at height is 11, 5 height is 9, 4 height is 7, then height is 5, 3 and 1. This is called fx and it is a discrete function. It is sampled at x equal to 1, 2, 3, 4, 5, 6. There is another fx that is again 2x minus 1 only, but that is sampled at x equal to 1.5, 2.5, 3.5, 4.5 and something like that. Then we went through this is called discrete function, because this is a discrete function. This is not a continuous function because the function has value only at x equal to 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5 and so on. Consider there is another function called gx, and gx is a continuous function. Consider it is a continuous function. If it is a continuous function, then we are calculating gx in two manners. One is when, okay, what is gx and what is, many times we have talked about it. Consider for odd number, I have x equal to 1, 2, 3, 4, 5, 6 like so. Between at x equal to 1, I have a height of 1. When x equal to 2, I have a height of 3. Between x equal to 1 and 2, can I take our area strip and it will go and hit gx, that is a continuous function. This area strip will be exactly same as fx at x equal to 1. Means fx at x equal to 1 will be integration limit x equal to 1 to 2 fx dx. Okay, I believe it is understandable. Fx at x equal to 1 equal to integration limit x equal to 1 to 2 gx dx. Okay, I mean fx at x equal to n. If I just make n, consider n, then it is equal to limit n to n plus 1. The lastmost side area will be n to n plus 1 gx dx. More or less, if I am adding all the odd numbers, then it will go from 1 to n plus 1 gx dx. Someone has to find gx. Okay, we are giving so many examples so that if someone is watching, then he will be completely clear what he has to do and then proceed upon. Then calculate for the even number and then subtract, because even number in negative and find the answer. Now we will start with another assumption. So last time we did assumption that x equal to 1, then height is 1. When x equal to 1.5, then height is 2. When x equal to 2, then height is 3. When x equal to 2.5, then height is 4. X equal to 3, height is 5. X equal to 3.5, height is 6. Okay. Now we will proceed upon here. It is sampled at half distance. Let's consider it is sampled at 1 distance only. At x equal to 1, height is 1. X equal to 2, height is 2. X equal to 3, height is 3. x equal to 4, height is 4, and so on. But we cannot take as a straightforward, because actually at x equal to 2, height is minus 2. In the examination, what is written in the examination? In the examination, it is written 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8 plus up to 33. Someone needs to calculate. This is what is written in examination. Now there are many ways someone can achieve this. Two ways we have already talked about. This is the third way. And third way is x x equal to 1, then height is 1. X equal to 2, then height is 2. Consider 2 only, but actually height is minus 2. X equal to 3, height is 3. X equal to 4, height is minus 4. X equal to 5, height is 5. X equal to 6, height is minus 6. Okay, let's compute the summation. Now let it go like this. X equal to 1, 3, 5, 7, height is 7, 5, 3, like so. Can we compute the addition of this? What do you mean? Okay, let's consider I'm plainly asking what is addition of 1 plus 3 plus 7 plus 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 and so on. If I divide into n different parts, then first part is 1, second part is 3, next part is 5, something like that. Okay, then what is each part? Then someone would say each part is 2x minus 1, because 1 is x equal to 1, 1 is x equal to 2, 1 is x equal to 3. But I am saying no, that is not true. Actually, 1 height is kept at x equal to 1, 3 height is kept at x equal to 3. Okay, then someone will say formula is x1, x. X means when x equal to where, now I can write summation x equal to 1 to n fx. This is what I want. Actually, I want 1 plus 3 plus 5 plus 7 and so on. Summation x equal to 1 to n fx, where fx is x equal to 1 plus x equal to 3 plus x equal to 5 plus x equal to 7 plus x equal to 9 plus x equal to 11 and so and so. X is now getting sampled at 2 gap. 1 and 3 2 gap, 3 and 5 2 gap, 5 and 7 2 gap. Okay, then how I can go with successive approximation? Now successive approximation, if x equal to 1, then height is 1. X equal to 3, then height is 3. Someone would say, why didn't you go for full calculation? 1, 2, 3. Because at x equal to 2, height is minus 2, minus 4, minus 6. I cannot go the way I can go. So let's compute the odd number first. X equal to 1, x equal to 1, x equal to 3, x equal to 5. If I take area strip, then x equal to 1 and 3, I have an area strip that will go up and it will hit gx. Gx, a continuous function called gx, at x equal to 1 and 3, 3 and 5, 5 and 7. This area will be exactly same as fx at x equal to 1. Fx, this is fx and that is x. Fx is x. At x equal to 1, x is 1. That will be equal to x equal to 1 to x equal to 3. This area strip, it will go up and it will hit another continuous function called gx. This area strip will hit gx. If this is gx, this area strip will go and it will hit gx. This is the area strip. What do you mean? I'm saying fx at x equal to x equal to limit x equal to x plus 2, 2, x plus 2, gx dx. I have to find gx now. Find a gx for which area between x equal to x plus 2. That area will be exactly same as left hand side fx at x equal to x. If I am able to find it, I got the solution for 1 plus 3 plus 5 plus 7, like that. Okay, now let's try. Let's try. Who stops? Let's try. Fx equal to x. Now I have to find gx. Let's put gx as x. Someone would say fx equal to x equal to gx dx. Gx will be dfx by dx. It will come as 1. We'll try with 1. 1 dx, it will come as x. X to x plus 1 is the limit because gap is 2, 2. So x to x plus 1. If I take any x equal to x, then I have a height at fx. If I take if I take if I take any x equal to x, then I have a height of fx, where that height there where the height will be this height of x equal to x fx. This height will be same as x to x plus 2. If x is 1, then it will go to 3. If it is 3, then it will go to 5. X plus 2. This area strip that will go and hit gx. Area strip that will go. Actually, it is very okay. The area strip that will go and hit gx means x to x plus 2 gx dx equal to fx at x equal to x. Means if I try gx at 1, then 1 and limit is x to x plus 2. That will come at 2. This side we have x, this side we have 2. So difference is there. It should be, now I have to multiply by x and divide by 2. Okay, so actually we will start with x by 2 again. So x by 2 integration will be x square by 4. X square will become x plus 2 whole square minus x square. That will come as 4x plus 4 by 2. That will come by 4. That will come as x plus 1. X plus 1. Wanted is x. We are getting x plus 1. I have to do something now. Okay. Now we started with x by 2. X by 2. I'll say 1 by 2 and in bracket x minus 1. We'll subtract with x, whatever someone understand. Or I'll say I'll take x by 2 minus 1 by 2, because x by 2 will become by 4 after integration. 1 by 2. We'll try this is successive approximation. So x by 2 will become x square by 4. X to x plus 2 will become again x plus 1 minus 1 by 2 x. X will be x plus 2 minus x. 2. 2 to 1 minus 1. Makes sense? X plus 1 minus 1 x. We got the result. Gx is x by 2 minus 1 by 2. We will proceed. Now what is the final summation of this odd number that starts from 1 and it goes up till n? What is the final summation? Final summation would be 1 to n plus 2, because if I divide this into sub area, first sub area is between 1 and 3, next is 3 and 5, last one is between n to n plus 2. So now if I say summation x equal to 1 to n fx equal to integration limit x equal to 1 to n plus 2, n plus 2, that is the main thing. Gx dx, where gx is x by 2 minus 1 by 2. Okay, that will come as x square by 4 minus 1 by 2x. What is x square by 4? Limit is 1 to n plus 2. 1 to n plus 2. That will form as n plus 2 whole square. N plus 2 whole square minus 1 by 4 minus 1 by 2. N plus 2 minus 1. That will come as n square plus 4n plus 4 minus 1 minus 1. That will come as n square plus 4n plus 3 whole by 4 minus 1 by 2. N plus 2 minus 1. N plus 1 minus 1 by 2 is waiting. Now if I take common denominator as 4, then whole term will become n square plus 4n plus 3 minus 2n minus 2n, and then again it has 1 minus 2. It will become, it will minus 2, it will become n square plus 2n plus 3 minus 2, 1. N square plus 2n plus 1 by 4. That will become n into n plus 1 by 2 whole square. Someone can try. Okay, what is the addition when n equal to 7? Then 1 plus 3 plus 5 plus 7. That will come as 7 plus 5 as 12 plus 3 as 15, 16. We'll try here. N plus 1 whole square. N is 7. 7 plus 8. 1, 8. 8 to the power 2. 64. 64 by 4. 64 by 4. That will come as 16. That will come as 16. 16. Was it 16? I forgot. 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 7 is 16. 1. Perfect. So we got, if I'm trying to add a number 1, minus 2, 3, minus 4, 5, minus 6, 7, then we have calculated addition of all the odd number, and that is n square, n plus 1 whole square by 4, or n plus 1 by 2 whole square. We got it. Okay, let's try for the even numbers. Let's try for, consider even numbers are positive, 2, 4, 6, something like that. Then in that manner, if I take any value x, then next will be x plus 2 again. Here also the same thing will come. Fx equal to, fx at x equal to x equal to limit x to x plus 2 gx dx. Then gx will come same, x by 2 minus 1 by 2. Now watch the integration now. That is the main thing. The final integration, if I'm trying to calculate, we have to keep the both the n into synergy. See, if I had taken n value, because at the end we will add it. 1 minus 2 plus 3 minus 4 plus 5 minus 6 is same as 1 plus 3 plus 5 plus 7 minus in bracket 2 plus 4 plus 6 plus 8, something like that. To have both added at the end, we must have n same. In that manner, consider that we are adding minus, we are adding 2, 4, 6, 8. Then we will keep n same. Means if I am saying my n is odd number, because this is what we had started with. Consider I want to add 2, 4, 6, 8. Then I keep n 9. If I keep n 9, then I am computing till n minus 1. In that manner, if I am trying to calculate the final area of gx will start from 2 and it will go n where we want up to n minus 1. So n minus 1 plus 2, it will go n plus 1. This is the most crucial part. So if I'm trying to add all the even number, it will go from 2 to n plus 1, where n is a number in odd number. That is the main. So 2 to n plus 1, gx dx, x by 2 minus 1 by 2 dx, x square by 4 minus 1 by 2x. Makes sense? X square by 4, how much it will come? X square limit is 2 to n plus 1. It will become n square plus 2n plus 1 minus 4. 2 square. 2 square minus 4. N square plus 2n minus 3 by 4 minus 1 by 2n. 1 by 2 x will become n plus 1 minus 2, n minus 1. If I take 4 as denominator, then full term will come as n square plus 2n minus 3 minus 2n minus 2n plus 2 plus 2. Net will become n square, 2n minus 2n go away. Minus 3 plus 2 will become minus 1 only. Okay, I believe I am all right. N plus 1 minus 2, n minus 1. N minus 1 minus outside minus n plus 1. 2 multiplied minus 2n plus 2. All right. So at the end we are getting n square minus 1 by 4. This is the summation if I take all the even number where n is in odd number, because we want to keep in sync with both. Okay, now let's try again. We'll try again. If I try again, now let's calculate 2 plus 4 plus 6. In that manner, we have taken n in odd number. So n is 7. If I want 2 plus 4 plus 6, then n I have to take 7. One more. So 7. So 7 square minus 1. That will come as 49 minus 1, 48 by 4, 12. It will be 12. 2 plus 4 plus 6 is 12 only. Okay, let's calculate 2 plus 4 plus 6 plus 8 plus 10. Then I have to take n 1 ahead, 11. 11 square, that will come as 121, minus 1, 120 by 4, that will come as 30. It will come as 30. Someone can try. 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 8 is 20. And 8 plus 10 is 31. Perfect. Now with same n, we have got odd number computation as n is n square plus 2n plus 1 by 4. And same n we have got here n square minus 1 by 4. Let's settle it down. N square went up. Now here we have 2n plus 1, and here we have minus 1. 2n. 2n by 4, n by 2. N by 2 is the net summation. This is what I think so. N square plus 2n plus 1 minus, there we have n square minus 1. So that will become minus n square plus 1. I'm sorry, plus 1, plus 1. N square went away. Now we have 2n plus 2 by 4. That will become n by 2. 2n plus 2. N by 2 plus 1. Oh, n plus 1 by 2. The answer is n plus 1 by 2. Okay, let's start what we did. In examination, it is written 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 up to 33. 33 is the odd number. Means n I can take at 33. Let's try now. 33. N plus 1 by 2 is the answer. 33 plus 1 by 2, 17. This is what we saw in the last session. 17 is the result. Okay, someone can try. Let's say we want, someone can try. Okay, how someone can try? 1 plus, or someone can try up to 11. 1 minus 2 plus 3 plus minus 4 up to 11. Then n is 11. N, answer is n plus 1 by 2. 12 by 2, 6. Answer will be 6. 6. Someone can try. 1 minus 2 minus 1. 3 minus 4 minus 1. 5 minus 6 minus 1. 7 minus 8 minus 1. 9 minus 10 minus 1. Minus 5 already we have seen. Minus 5 plus 11 is 6, 1. Okay. Now, this is one concept that we can try. Now, can someone take it as an assignment? Can someone take it as an assignment? Okay. What is the assignment? The assignment here is, there are many ways someone can compute. One way is considering n as not as odd number reference. N as a reference we have taken, and that is in odd number. Can someone revert it and make n as a reference in even number? So if I want 1 to 33, then even number will come into the reference, and where where it has to be settled down in that manner. Or this is the one way someone can try. Another way is, if someone is finding the summation 1 to n in odd number, 1 to n in odd number, then it is coming all right. That is n into n plus 1, sorry, n plus 1 by 2 and full whole square. But when we computed for the even number, that came as n square minus 1 by 4, then n we took as an odd number only as reference. Can we take as an even number as reference? Means 2 plus 4 plus 6 plus 8 plus 10 up to n, where n is even number only, not the odd number. In that manner, can someone try? Now I have summation in odd number at n into, I'm sorry, n plus 1 by 2 whole square, and whatever will come as an even number summation in n, where both n are different. One n is taken in odd number, one n is taken in even number. Then how we can merge it? That is a big question that someone need to answer. But someone can try. Try the computation of 2 plus 4 plus 6 plus 8, where last term is n. 1 plus 3 plus 5 plus 7, last term is n again. But when you try to add both numbers, then one n is even and one n is odd. How someone can merge it and come to the solution? Someone can take this as an assignment. Okay, and someone can proceed. We'll take one more session on it. This is mind-blowing, thrilling. Otherwise, someone can proceed in the traditional way, that is fx equal to minus 1 to the power x plus 1 into x, or x into, in bracket, minus 1 to the power x plus 1. Why we did not could not go through this way? The reason is that minus 1 to the power x plus 1 integration is undefined. Differentiation is also undefined. It would come in term of logarithmic of minus 1, natural log of minus 1, which is considered as not defined. So that is the problem. Otherwise, we would have proceeded in that this manner also. But anyway, someone can try. Who is stopping it? If something end is hitting, then that is giving a chance to invent something. Then only someone will invent. How someone can tackle through successive approximation where fx equal to minus 1 to the power x plus 1 come down into x. Then we need not take two series. One is odd series and one is even series. This is what we are taking and we are merging it. Someone can proceed directly the way we did earlier. Some we proceeded directly, and this is how we did. So someone can do in this manner. Okay, whatever we did, whatever we could do, it is also not available in any of the book. This is a generic procedure to compute the series summation. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.